passengers might think that this would soon happen. What actually happens is different. The rail deck remains unaffected by the earthquake. Can you explain how this is possible? The answer lies in the spherical bearings. The lower part of each bearing moves with the ground, but this motion does not transfer to the upper part. To isolate the rail deck, the Chenab bridge also makes use of expansion joints. The way expansion joints work is a feast for the eyes. The movement of the box-shaped rubber structure makes this functioning possible. To understand why this bridge is safe, even in seismic zone 5 area, let's take a cross-section of its foundation. You can see a lot of interesting stuff here. This was the shape of the mountain before the construction work started here. An irregular sloped mountain. The minimum slope of this mountain was 43 degrees, and the maximum was 77 degrees. The first job of engineers is to cut these mountains so that the shape is suitable for construction. The rocks in these mountains are not so strong. It's a material called dolomite. Not suitable for erecting a strong foundation. Excavators were used in the initial stage of shape correction. After that, they employed a technique called pre-splitting. In pre-splitting, a lot of tiny explosives are kept in a close distance. Connect them together, and they explode. Normal explosives break unnecessary portions of a rock. Using pre-splitting, you'll have greater control over the rock to be broken. The mountains look more clean now, but how to make them stable? The engineers used 3 methods to stabilize the slope: grouting, the use of anchor block, and shotcrete. The Himalayas are young mountains. The rocks in this region have a lot of minor cracks inside them. In the grouting technique, we inject cement into these voids. The cement acts as a glue, and the rock becomes stronger. You might have seen a lot of strange-looking blocks in construction photographs of Chenab Bridge. This is a smart slope stabilization technique called anchor block stabilization. In this method, the workers make holes on the slope. After that, they insert a special rod with a lot of tendons in it. In this project, they used divvy-dag tie rods. Now it's time for grouting. Once the grout is hardened, a block is kept on the rod. Now comes the use of a powerful hydraulic jack. The hydraulic jack pulls and keeps the steel tendon in extreme tension. After that, using a wedge arrangement, the steel tendon is kept in tension, even if the hydraulic jack is removed. Now, can you predict the force produced by the concrete block? The steel tendon in tension wants to reduce its length, but the block is not allowing